Yo, what's up, wastemans? Oh, Carl, do you even want to hear it, mate? It's not looking good, bruv. It's not looking good. We can rate out of 10. Yo, Finn, what you saying, dude? Yo, Hassan, Caesar, what's up? Samir, what's up? What do you call an artist that rates another artist's song? I don't know. What do you guys think? Irena, what's up? MD, walk through. What you saying? What do you call an artist that rates another cosiner? Uh, I don't know, guys. What do you think about that? What do you think about Carl's joke? Top crowd. Hey, yo, what? Hey, yo, is this like third party embarrassment? Miran, what's up? Rue, what's up? Retire. Samaya, what's up? Hey, yo, Carl, man. That's going down in history. What? Oh, I had another joke. I don't know if I told you guys. It was Oh, I remember. Why was the why was the fraction apprehensive about marrying the decimal? Okay, so that's my joke. Why was the fraction apprehensive about marrying the decimal? Because it didn't want to convert. Hey, yo, nah, that was better. That was better than Carl's. I don't care what you guys say. That was better than Carl's. Carl's didn't even make any sense. Hey, yo. All right. What we got? What we got? Today we got who laughed? Sienna, what do you mean? I can't tell. Omar, what's up? Now you're here for the jokes now, Samir. Today you lot, what I'm gonna do is I'm gonna show you the basics of differentiation in year 13 and also differentiating sine and cosine functions. So I'm gonna show you what you're used to differentiating, but in different way, and also differentiating sine and cosine functions. And at the end, you guys were all asking me, a lot of you were asking me last lesson. I'm going to put at the end some information about the main course that starts in September, because it's now open to join. So I'll tell you guys about it at the end. But differentiation actually in year 13 is actually really enjoyable. It's much easier than you might anticipate, which is great. Yeah. Now, you guys in year 12, how would you differentiate something like this? I know it's power 6, but if you were in year 12, how would you differentiate something like this? What would you need to do? What would be the play here? Exactly, Lewis, you'd have to expand, right? Now, ain't nobody got time to expand power 6. Even if you do have the binomial expansion, yeah, there's nobody that's going to be expanding power 6. Yo, Ashna, welcome back, dude. Hope you're doing good. Results day tomorrow, man. It's looking good, man. It's looking good. But I'm going to show you guys how you could expand this. Actually, it's a good point there, specialist. So you actually don't need to take out a 2. Remember, if you're going to use the n choose r method, that just needs to be a +1, right? So I'm going to show you guys a different way. I'm going to change this in such a way that you are used to differentiating. So we're going to have y equals, and you're going to see how it's a very easy process. So I'm going to show you guys the long way so that you guys understand what's going on. And then I'm going to show you the easy way of doing it. So what I'm going to do is I'm going to let what's inside the bracket equal u. Yeah? Because then it changes to this. Y is u to the power of 6. Yeah, where u is 2x plus 1. Yeah? Now, you guys know what this would differentiate to. What would that differentiate to? And I want you to tell me d something by d something equals something. So that you definitely know how to differentiate that now. Yeah, that's just standard year 12. How would that work? Not dy dx. It'll be dy by Nearly Lewis. So you guys are, there you go, MD good. So you're differentiating y. So guys, it's rearranged for y. You're differentiating y with respect to u this time, right? Because u to the power of 6. So we differentiate that, it's 6u to the power of 5. So that you guys are used to. You're not differentiating with respect to x anymore. Now this, d by d something equals something. What would it be in this case? What would it look like? Don't worry, JMB, you're getting used to it. But you guys are going to see how simple it is. Omar, good. Andy, good. So here, guys, it's rearranged for u, right? So it's going to be du, and it's in terms of x. And that differentiates to what? Well, that right side, Soham, good, is 2. Okay. Now, we're not done yet. Because we obviously wanted dy by dx. Yeah, the whole original function is y in terms of x. So we want dy by dx. Now, guys, these are just fractions. I'm going to put these two dy by du and du by dx next to each other. Now, what goes in between? Is it add, minus, times, or divide so that it simplifies back down to dy by dx? What do you need to do? Multiply in it. JMB is with one n, my friend. I've had major beef with the GCSE kids. In it is with one n. Good. We multiply so that the du's cancel. So we multiply so that these cancel out, right? And you're still left with dy by dx. So let's put things in. We need to multiply these together. Now, the way I multiply them, guys, I'm going to do it in a very specific order because I'm going to explain in a specific way. So, it's going to be 2. So, I'm going to write the 2 first. Yeah, that's coming there. Times 6u to the power of 5. Yeah, I did them the other way around, and I'll explain why in a second. Now, we obviously are not done yet, because then dy by dx, 2 times 6 is 12, and u is 2x plus 1 to the power of 5. And that is it. Yeah. Now, this is the longer way of doing it. I'm going to establish the shorter way of doing it. Okay. Check this out. This was 2 times 6, and I'm going to keep that u as 2x plus 1 to the power of 6, yeah? To the power of 5, sorry. And we're going to establish a rule here. And it's a very easy rule. So, let's go right back to the top. This differentiates to. This 2, guys, where did that come from again? That 2, where did it come from when you look at this original function? Where does that 2 come from? Where does that 2 come from? The 2x bit, so the exactly Ethan. So guys, look at what Ethan's written. The differential of what's inside the bracket. Yeah. So let's write that down. So here, we're just going to make a note. Differentiate what's inside bracket. Okay. And then we multiplied it by 6, 2x plus 1 to the power of 5. Now, what are we essentially doing here? When you look at the original function, this. What essentially are you even doing? What is that process? Yes, it's on. Bring the power down and decrease the power by 1, which is exactly what you guys knew from year 12, right? This is known as a power function, yeah? So you guys might have learned it as chain rule. Now, you got to be careful with what you say about chain rule. Chain rule is actually this. What we did here, that is chain rule. Yeah? What you guys learned about bringing down the power, knocking one off the power is differentiating power functions. That's not chain rule. That's just specifically how to differentiate power functions. And that's what this is. So, differentiate power function like normal. Okay? And that's it. Guys, it's very simple, right? So all that's different to year 12 is that you're just differentiating what's inside the bracket first, and then you just differentiate the function as a power function. So when we get to like really difficult year 13 stuff, we're going to first identify what type of function it is. Yeah, what type of function is it? We're going to differentiate what's inside the bracket. Now I call that the angle. So this here, what's inside the bracket, I call it the angle. Now the reason I call it the angle is when we do trigonometry, we're just going to be using consistent terminology. So this is specific to the way I teach things. I call that the angle of the function. Yeah? What do you mean, Sienna? Because in year 12, you just learn how to differentiate really basic power functions. Now we're going to be differentiating like more difficult composite functions. Okay. Apparently differentiation integration weren't even in year... Yeah, they are, Ruwei. They definitely are. Okay. So, firstly, guys, when we differentiate, we're going to do it one step at a time. So what's the first thing we do here when differentiating this function? What is the first thing we're going to do when differentiating this function? So it's doing steps. So we differentiate, good. What's inside the bracket? What does that give us? So we don't need to write any of that Ruwei anymore. So first I'm not gonna tell you explicitly, but I want you guys to tell me in steps, and then I'm gonna make you guys do it all in one go. Yeah, okay, good. So when you differentiate what's inside the bracket, you get 3 multiplied by what? So guys, tell me what we're gonna multiply it by. 3, Omar, 3x minus 2 is the angle. So we're gonna differentiate the angle first, which gives us 3. Yeah, and then what do we multiply it by? More than that, so 5 what, guys? So look at what Hassan's done. 5 what? 5 what? Nice. So you bring down the power, knock one off the power. Nice. You've done it. It's pretty simple, right? We don't need to expand any brackets. Sweet as a nut, sweet like Tropicana. Let's do the same thing here. Now, what do you recommend we do first with this function? Knowing what we have to do first when we get to the differentiating. Any recommendations? Think about your simplify the fraction. I know what you mean, Omar, Ethan, good. So the first thing you guys should be doing is rewriting 3 over x, because you know you're going to have to differentiate what's inside. So as you guys are saying, that's 3x to the minus 1. Nice. All right. Using my terminology, guys, can you differentiate the angle? Differentiate the angle for me. Izan, yes, plus C, obviously. I'll teach you. Well, if you guys join the full course, I'll teach you how to integrate like a professional. It's actually pretty simple. Nice, Ashna. Lewis got the same as well. Yeah, so you bring down the 2. So you get 4x. Good, knock 1 off the power. Bring down the minus 1. So that'll become plus 3. Then you knock 1 off the power, x to the minus 2. Let's keep that in a bracket, good. Times what? What are we going to multiply that by? Ashton, are you saying next year? Because you're doing further maths, right? Unfortunately, I don't have a further maths course just yet. For what, guys? For what? There's no more. Carla, what is this? Hey, yo, you guys are so lazy. Oh, my days. So you bring down the 4. And then, yeah. 2x squared. Minus, so we keep it the same. We just type further maths. Nice. 3x to the minus 1 cubed. Right, we bring down the power, knock 1 off the power. Now, the way I might rewrite this is I'll bring this 4 to the front. And I might rewrite everything back as a fraction. So this will be 3 over x squared. Actually, wait, what have I written that? 4. 3 over x squared. 2x squared minus 3 over x. Nice. All right, for part C, what are we doing? Rohan, we're only differentiating once, aren't we? But you can keep going if you want. Yeah, unfortunately not, Ashna. I need another maths teacher full-time to help me out. So I have to rewrite the fraction. It's a bit like binomial, right? No, we don't need to use quotient here. I'm not teaching you guys quotient today. So we bring up the denominator. Power minus 3. Okay. Now, this 4, guys, doesn't do anything. It's just a multiplier. So we're going to write 4 times. Now, can you guys differentiate this for me? The whole thing. I want you to do this whole situation for me. It's very simple with this function. Can you tell me the two things individually? You have this times this. So can you tell me with this function? It should be much easier for you guys to tell me. So it's going to be this times this. What's that going to look like? Man like Lewis Capaldi and that. Let's go. To be fair, I haven't looked at it properly, but... Oh, you've simplified it as well. Okay, you're all saying 5. It's looking good, bruv. Should be minus 4. Oh, yeah. So first thing we're going to do, guys, we're going to differentiate the angle. That'll be 5 times. Then we just bring down the power, minus 3. Knock 1 off the power, which will be minus quattro. 4 times 5, 20 times minus 3 is minus 60. 5x plus 9 to the minus 4. Simple, right? For part D, what are we going to do? Part D, what are we going to do? Partial derivatives are not in normal A levels. Normal A level maths. Although on my TikTok, I upload some partial derivative. I've uploaded like 3 videos on partial derivatives. It might be in like FP3. I can't really remember. I haven't really looked at FP3 in further maths. Okay, good. So we bring up that as a negative half, right? So we're going to write y is 3 lots of 3 minus 2x to the minus half. And again, guys, this 3 at the front is just a multiplication. So we have dy by dx is 3 times. Now, can you guys differentiate this using the exact same logic as I did before? Can I do a video on partial differential equations? I mean, I could. I'll probably most likely just upload a TikTok video on it. If you guys don't have TikTok, then on Instagram, there's NeilDoesMaths. I upload the same videos. So obviously I got my main page, NeilDoesMaths. But I have NeilDoesMaths on Instagram. If you guys want to see the A-level exam questions that I post to my TikTok. Because I know some of you guys don't use TikTok in it. So follow that if you use Instagram. Or if you don't have either, then it's not looking good, bruv. It's not looking good. On YouTube, it's annoying because Shorts is literally 60 seconds. That's it. So you can't really upload anything. It's a bit annoying. They stay true, YouTube, innit? Okay, I see a few of you putting some answers there. Yes, clips. Is on, yeah. And Khalid, it's Khalid, 9-3. ¿Qué pasa? Khalid, do you have a shift button on your keyboard, yeah? Bro just presses 9, expecting me to see that as a, as a bracket. Okay, so we differentiate the angle. What's inside the bracket first? -2 times. Bring down the power, -1/2. And then knock 1 off the power. -3/2. Now, -1/2 times -2 cancel. And we're left with 3. 3 minus 2x to the -3/2. And that's it. Boom. Simple, mate. Biggie. Is this the same as specialist maths for Australia? I'm not sure, Biggie. With the Australian curriculum. I mean, maths is maths, right? It just depends on which year that you'd be doing this. So I'm not sure. You have to have a look. How many of you guys remember your first principle? So I'm going to show you guys what sine differentiates to. Well, sine does differentiate to cos, and I'm going to prove it to you. This is a standard 4-mark, maybe sometimes even 5-mark question in the exam. So, do you guys remember your first principles formula? Do you guys remember your first principles formula? Is on. We have not done the addition formula. I will tell you guys what it is. Usually, I would have taught you guys the addition formula, but I'll just tell you. So, in the in the main course, guys, I teach differentiation after doing all of trig. But I think it's nice for you guys to learn this with me. I won't have done the additionals with you yet, but I'll just tell you what it is for this example. It's a very small part of the proof. F of x plus h minus f of x all over h clips. Yes, and Lewis. In fact, I recorded a video on the addition rule to try and upload to Instagram, but it was a bit long, I can't lie. So it's the limit, so don't forget it's the limit as h tends to 0 of f of x plus h. So the formula is the same no matter what. Minus f of x all over h, yeah? Now we want to differentiate sine x. Yeah, so my f of x is sine x. Okay? So this f of x here is sine x. Now if f of x is sine x, what is f of x plus h? How would you write that? We're going to do that here. What would that look like? If f of x is sine x, what would f of x plus h be? Let's see, Lewis. Is on. Nice, guys. So you're replacing the x's with x plus h. Yeah? So the angle changes to sine of x plus h. Yeah? Now, one thing you guys would know immediately what you would want to do with sine of x plus h. It's known as the addition rules. Now, what I want you guys to know is that this is not the same as this. This is known as the distributive property of algebra. It does not work with trig. Yeah, so if you've not done the additionals yet, which most of you haven't, yeah, maybe make a note of this at the top. Yeah, maybe make a note up here on your workbook. Yeah, so it doesn't work like that. It's known as the addition rules or compound angle formulae. I'm just going to tell you guys what it is because I haven't shown you it in the summer courses. It's very simple. It's very, very simple. Once I prove it to you, I always prove the formulas, guys. I never ever just tell you formulas. In the main course, I'm going to show you how you derive it through right angled triangles. Now it looks like this. It goes sine x. Actually, the way to remember, the sine expansion goes sine cos, sine cos. Yeah, so guys, write this down. Sine cos, sine cos. It's a very easy expansion. Yeah? Sine cos, sine cos. XH. Yeah, here's my angles. XH. and then just swap them around, hx. Yeah, so xh, hx. And sine, the way I kind of tell my students to remember this, s means the sign stays the same. So the sign in the middle stays the same. So it looks like this. Yeah, that's the expansion for sine. It goes sine, cos, and you just switch the angles around. Yeah, and that's it. It's a very simple expansion once you've seen where it comes from. Yeah, so this is the expansion for sine of x plus h. Now we're just going to sub it in. So the main bit is how do we manipulate this within the bracket. Okay, is on. I'll show you on the main course. Sine x cos h plus sine h cos x minus f of x. Yeah, remember f of x was sine x. Yo, Ted, what are you saying, dude? Bun the formula book. Don't worry. Whenever you see these quotes, guys, it's all my old OG students coming in. How you doing, Ted, man? Make sure you let me know how things go tomorrow, yeah? Okay. Yo, come on. Now, guys, look at the numerator. Do you notice anything that is common between terms? Do you notice anything that's common between terms? I'll just color code it so you can see what we've substituted for what. Ted, do you know me and Cotillia are going on the radio today? The sine x. Now, they all have sine yes, but specifically, the first and last term both have sine x. Yeah? So we can factorize. Bun the box method, Darren. So here, can you see they both have sine x? We're going to collect them together. So first, I'm going to write them next to each other. Which radio? I'm not sure, actually. Greatest hits? Have you heard of that? So you have the first term, sine x cos h. Then the last term, minus sine x. And then you have the last term. Do you walk through specialist? What radio station's that? Why is people yapping about the radio? Soham, you had to be there, man. You have heard of that. All right, tune into the greatest hits on the radio. I think it's 2:15 we're hopping on. Club Asia Radio. Nice walkthrough. How many people do you have listening usually on average? Now, guys, with common terms, what do you usually do? 100,000. Ayo, specialist. Drop me a message, dude. Let's get me and Cotillia on this radio station. Let's do some beatboxing. All right, factorize. Can you guys factorize out sine x? What would it look like? Clang, nice. How do I get in contact? I love to interview on my show. Can you DM me on Instagram? Ayo, Carl, where you getting tan x from, bro? Okay, so. Nice one, walkthrough. So we have sine x. When you factorize that out, tan x just spawned. I was going to actually mention that darker. So guys, when you see cos h, that's not cosh. It's cos of the angle h. Yeah? Minus 1. Then we have that last term. So this is sine h, not shine. Exactly, Rue. All over h. Now, the next thing we do is we are going to split the fraction. Yeah, we're going to split the fraction. Leonie, yes, we are going to use the identity. But first, we need to split the fraction. So look at this. We have the limit. So just like when you integrate, guys, you integrate individually. When you take limits, the same thing happens. So you have sine x cos h minus 1 over h plus the limit as h tends to 0. So we're going to take the limit of each individual fraction. Yeah, sine h cos x over h. Yeah? It's not a proof is on. It just is what it is. Just like you differentiate term by term, you limit term by term. So, the next thing, as h tends to 0, we're cooked. Huh? Now, the limit, guys, the limit here depends on h, right? Which means that sine x here is a constant. It doesn't change as h tends to 0. Yeah, nice one, Ted. I'll speak to you tomorrow, dude. Good luck, good luck. So, guys, sine x does not depend on h, right? So we regard it as a constant. So it does not need to be within the limit. We can take it out. In the second limit up here, which term can we take out? Because it doesn't change. Which term makes no difference? Cos. Good. This cos does not depend on h. We can take it outside the limit. Okay. So we get sine h over h. Nice. Now we're basically done. If you look at the top, can you see there's assumptions? They come from what's known as the small angle approximations. As h tends to 0, sine h over h tends to 1. And cos h minus 1 over h tends to 0. Can you see that cos h minus 1 over h is over here? That tends to 0. It means tends to, Carl. So it means sine x times, as h tends to 0, this tends to 0, plus cos x times, now sine h over h tends to 1. And there you go. We are left with cos x, aren't we? And that is how we prove that sine x tends, or sine x differentiates to cos x. Yeah? Now, when you come to actually computing these in year 13, some steps you guys don't need to show. For example, I'm showing you guys every single step to this, but as you get more experience, if you guys see my videos on TikTok and stuff, I don't show this step. I straight away go from this line to this line, straight away just factorize it. And I don't do this step. I just go straight from this to splitting and taking out the terms that don't involve h. So don't involve h. So it's a much quicker process than what I've shown you at first. Yeah, but as we practice more and more and more, there's two steps you don't really need to show. Yeah, but it's actually it's one of those things where you just need to watch it again. It's actually a very, very, very simple proof. It's just because you've not seen it before. But where's Asher? Are you still in the chat? What did you think of the proof after you did it like 2 or 3 times? Asher's one of the OGs. It's one of those things, guys. It's you see it once for the first time and you're like, wait, this looks really strange, because you're used to doing basic stuff in year 12, right? But this is a proper proof. But the main thing that you need to know, guys, some of you are just not listening. I said where these tends to, it comes from the small angle approximations. Yeah. So here, guys, some of you are clearly not listening. You need to follow along. Otherwise, just go back on the stream. Yeah. All right. So prove using the chain rule that sine of f of x differentiates to f dash x cos f of x. So I just proved this to you, that sine x differentiates to cos x. Now, another proof, I'm not going to do it today, I give it in my homework, is to differentiate cos x. Now, cos x differentiates to minus sine x. Yeah? So, I'm going to show you how you differentiate any kind of iteration of sine. So, sine of f of x means like sine of x squared, sine of x cubed, anything. Let's write like this. Yo, Ren squared. What are you saying? Now, I want to differentiate that. Going back to the first slide, guys, what did I tell you to do when differentiating something that we don't really know how to differentiate yet? What did I tell you guys to do first? Because then we're going to turn into something that we have seen before. What did we do in the first slide? Identify the functions used. What is that? Good, Hassan. We make it equal to u. And Soham, yes. So it's about differentiating what's inside. And we did that by doing a u sub. Yeah? So, Aiden. So we're going to let u equal f of x. Yeah? So we get y equals sine u, where u is f of x. Can you guys differentiate this? What would it look like? Remember, we've just proved what sine differentiates to. Can you guys differentiate that? What would the notation be? I want to see d by d something is something. D by d something is something. So cos u is what? So sine u definitely differentiates to cos u. What's that equal to? D what by d what? dy, good, because it's rearranged for y. And you're differentiating with respect to u, right? So dy by du is cos u. You guys have just used this property here. Now, this is a bit more of an interesting one. What does this differentiate to? U is some function of x. Now, I've generalized this. Let's think about what the notation is. So this is more about notation. This is more about notation. Carla, yeah, will be du by dx equals Ishak f dash x. Good. So du by dx, you're differentiating u with respect to x. The notation for the differential here is f dash x. Yeah? And then what do we do to the two functions to get dy by dx? What do we do to these two functions to get dy by dx? You times them. Good. Now I'm going to write, remember guys, I always wrote this second one first. It's f dash x times cos of u, where u was f of x. And that's it. You guys have proved it. Now, guys, this is the exact same layout as I've shown you before. So if you have this, the first thing you do is you differentiate the angle. Yeah? Then sine differentiates to cos. And then the angle stays the same. It's very simple. You differentiate the angle. Sine differentiates to cos. And then the angle stays the same. It's a very simple process. Remember, guys, all over here, do you see the angle that I called? Always stayed the same, right? Always stayed the same. That's why I called it the angle. So, you differentiate the angle. You say, what type of function is this? You differentiate that. Angle stays the same. Yeah? Guys, this is why when I teach differentiation, it's a very consistent three-step process. And it doesn't matter what I give you, you're going to always apply this three-step process. And it's very simple. Yeah? So if I want to differentiate sine 4x, what do you do? Maybe you guys can do it all in one step. Do it. So the steps are differentiate the angle. Sine differentiates to what? Angle stays the same. So Kai, you're basically there. Last step. There you go. Good. Nice. There you go, guys. Easy. Easy peasy. Squeeze the lemon. You differentiate the angle first. 4x differentiates to 4. Sine differentiates to cos. Angle stays the same. Simple as. What about part B? See what you guys come up with. Remember, guys, so sine goes to cos. Cos goes to minus sine. So remember, cos goes to negative sine, not just sine. Yeah? So it goes to negative sine. So I want to see what you guys come up with. I'm going to show you guys through my process how it works, and then I'll simplify it, yeah? Times minus 9. So 3 just stays as 3. Yeah, exactly, walk through. So 3 is just 3. That's a multiplier. The next thing we do is we differentiate the angle. 1 minus 3x differentiates to minus 3. Then cos differentiates to minus sine. Then the angle stays the same. So all you guys just need to be aware of is that cos goes to negative sine. And yeah, that's going to cancel out the negative. So it's actually 9 sine. So can you see how I write it, guys? I want you guys to write it like this. Yeah, so these 3 things, that's how I want you to write it. So you don't have to simplify it like you guys tried to do. Do that 3-step process when giving me an answer, and we'll simplify it together. Yeah, but it's simple, right? You just need to practice a few times and you're good. All right. Sine of x to the power of 4. It looks a bit strange, but guys, apply the exact same process. Differentiate the angle. Sine goes to what? And the angle stays the same. Keep it simple. I can give you guys crazy questions and the process is still the same. Yeah? The process is still the same. Kai, you're very close. So when you differentiated x to the power 4, you got 3x. Then you're just missing something there. Just something small. Tim, I see you. Sienna, you're with your x power 4. You bring down the power first, right? Then you're good. All right, nice, guys. So we differentiate the angle. X to the power 4 differentiates to 4x cubed. Sine differentiates to cos. Angle stays the same. Simple as. Yeah? Keep it simple, dive. Now, part D is an interesting function. What does that look like to you? 4 cos cubed x. How does that work? Well, I mean, I always told you guys to differentiate the angle first, right? What's the angle in this case? I see you, it's on. 2 functions. So J and B, you could use U. I'm going to show you guys how to do it without U. So the angle is x, right? Don't write anything down just yet. But the angle is x, right? So I would always tell you guys to differentiate the angle, which would be 1. But then you'd be thinking, cos cubed. Have I shown you guys how to differentiate cos cubed? Have I shown you guys how to differentiate cos cubed? No, I've shown you guys how to differentiate cos, yeah? So, the point, cos. I mean, you're not on the, you're close, Ruwei, and now some of you were talking about it before. This is actually a power function. Even though it has cos in it, it is actually a power function. We write it like this, 4 cos x cubed. Yeah? So, when we differentiate this, we actually differentiate it like we were doing over here. Yeah, Pavan function, Ashna. I forgot about that. So guys, if you've been following me on TikTok long enough, you know I call these Pavan functions. So I actually need to bring that back. Yeah, we call this a Pavan function. Big up Pavan and that. So, when we differentiate this as a Pavan function, we have 4 times. What do we differentiate first? Izan, do you actually listen, my friend? I literally just said what Pavan is. Brev, come on, Mike. Are you playing a game simultaneously or something? Okay, what's inside the brackets? Yeah, no, good. The angle. Yeah, so guys, you just need to differentiate cos x. And yes, that goes to minus sine x. So write that down. So we differentiate the angle, minus sine x, times what goes next? So 4, differentiate what's inside the bracket, and then what do we put afterwards? What goes afterwards? What do you mean, Nick? Eddie, what's the full thing, though? Pavan sounds like the Donny. Don't just go to random people and call them Pavan, yeah? Alright, good. So we bring down the power. Knock one off the power. There you go, guys. Nice and simple. 4 times negative 3 is minus 12 sine x. And then you could write this as cos squared x. Nice. So guys, look at part E. What we're going to do first. My cotta. Nice. Bro thinks 4 times 3 is 12. Wait, what? Ayo, nah, darker. Don't do this, man. Wrong question, Kai. Hey, yo. Guys, come on, man. It's not that. It's not even midday. Alright, so. We're going to rewrite it, nice, as a power function. Yeah, as a Pavan function. It's sine cubed. So we have 2 sine 2x cubed. Now, when we differentiate that, we have this 2 at the front times differentiate what's inside the bracket. So, guys, what does sine 2x differentiate to? It's like part A. What does sine 2x differentiate to? Nearly, Alex, you forgot about the angle. So, guys, don't forget, what do you do first? What do you do first? Ethan, JMB, good. Nice. So, guys, remember, sine 2x, you differentiate the angle first, which is 2. Sine differentiates to cos. Angle stays the same. Guys, remember the 3 steps I'm saying. Every single time it's the same. Multiplied by what? What goes after? 9. Baby, yeah. Na, 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 na. Good, bring down the power. It's a Pavan function. Yes, we're going to bring down the 3. Knock 1 off the power. Simplify. 2 times 2 times 3 is again 12. Cos 2x. And then here we can write that as sine squared 2x. Big up Pavan in it. Nice. So guys, you're already able to differentiate pretty tough functions. Yeah. So, part F. What do we do first for part F? What a beautiful function, mate. Increased aura for everyone, for real. So differentiate what's inside the bracket first. Alright guys, can you all have a go at differentiating what's inside the bracket? Term by term, go for it. So go term by term. You have the 2 sine 3x, do that separately. Then you have the minus 3 cos 2x, do that separately. So like this is a bit like part A, and this one's a bit like part B, and I'm put them all into one question. Really testing you guys, mate. Really testing you guys. Bracket. Get baza. Darker got 6 cos 3x plus 6 sine 2x. Sienna, the only thing you've missed out is not differentiating the angle first. So you know your sine 3x, you differentiate the 3x first. That's 3. That will join the 2 at the front, right? So just double check that one. And then for the second term, the cos goes to negative sine. You adjusted for the negative, but you didn't change the cos to a 2. Cos to the sine. Okay, so it looks like you're all getting about the same thing. So we have, this is Sigma Maths. There's someone on YouTube called Sigma Neil equals EK Gundogan. I think he's in my GCSE class. It's like, what is that name? So 3x, that differentiates to 3. That comes to the front to make 6. Sine differentiates to cos. Angle stays the same. Okay. I know it's a crazy username. Now for the next one, the angle 2 differentiates to 2 to join the 3 and make 6. So minus 6. But then, guys, cos differentiates to minus sine. And that negative will join this negative to make plus 6 sine 2x. Nice. Then what do we write next to it? If you guys want to be a bit lazy and just do this for what's inside the bracket, you can. Yeah. 2. What? Ayo, nah, Carl, that is even worse than your joke at the beginning of the lesson. No, you don't need to let it be you, bruv. This is the easy bit. You've done the hard bit. You differentiate what's inside the bracket. Easy peasy, squeeze the lemon. There you go, Ariana. Good. So you bring down the power, 3. Then you knock 1 off the power. That'll be squared. Yeah? Now, there's actually another thing we can do to clean this all up a bit nicer. Can you guys see it? What do you call yourself with no knees? Huh? No, that's not the joke, man. Nah, Darker, you're ruining it. It's what do you call someone that has no shin? No, not Neil. No, what do you call someone that has no shins? You call them Tony. Hey, yo, stay on topic, man. P comedy. Is anyone called Tony in the chat? The humor's broken. So what you guys should have noticed is in first bracket, you see there's a common factor of 6 nice Tim. You can factorize that out to join this 3. 6 times 3 gives you 18. Then in the first bracket, you just have cos 3x plus sine 2x. Then you just have the second thing, right? Nice. And that, guys, is a very tough function to differentiate. So why don't you guys give yourself a pat on the back, mate? Give yourself respect to Tony in that. Big up, Tony. What was I going to do? Oh, I remember. So, guys, what I'll do now is I'm going to very quickly... It's not bad. No, trust me, guys. Differentiation is actually really simple. As long as you have this 3-step process, which I've shown you, you can actually differentiate everything. When I go into year 13, I'm going to teach the class, not the teacher. That's usually what happens with my students, because I end up finishing year 13 maths. The whole of pure gets done by December. So my students always work way ahead of everyone else that we can do loads of papers. But let me tell you guys a bit more about the course, because you guys were asking about it. So I got my team to do a very nice set of slides for you guys. Is this as hard as differentiation gets? No, Frank. There's a lot of stuff that comes with it. Yes, Freya, I do stats and mechanics. I finish the whole specification by February. And then we just do papers. Yeah. So this is the overview of year 13 maths. So it goes from September to May. There's 108 hours of lessons, 72 exam style homeworks with video solutions. So basically for every single lesson, guys, there's 10 questions. And for every single question, there are video solutions. So if there's 72 lessons, there's 720 homework questions. And for every single one of those, I've done video solutions for. So you know exactly how to answer every single question. Yeah. And also, this is being rolled out properly this year, is at the end of every single month, there's a monthly assessment for everybody. So just every single year, guys, you're getting more and more and more. Yeah. We're trying to provide you as many resources as possible to get you the top grades. Yeah. Now, there's 2 packages you can have, either the Pro. The only difference is that the Pro, you have a mentor. a personal mentor who helps you out outside of lessons. Yeah. Now, the thing about the mentors, guys, is that they are all handpicked by us and they all go to the top universities. So you're talking about Oxbridge, Imperial, UCL, Warwick, these kind of unis, and they're there for you to, basically bug them as much as you want for help. Yeah. But for everybody gets live lessons twice a week. You get recorded lessons. Everything's recorded in case you miss anything. Professionally made workbooks, which you guys are using right now. Video solutions, and access to a vibrant student community, which all the current students will be able to tell you about now. Some of them are even in the chat. Now, what my team have done is they've analyzed the prices of more than 1,000 tutors, and they've discovered that beginner tutors, they charge about 25 to 30 pounds an hour. There you go, Samaya. Samaya is part of the course. She knows about the online communities and the quality that we deliver to you guys. So beginner tutors will charge between 25, 30. Intermediate tutors, 40 to 80 pounds an hour. And highly experienced professional guys, they would charge between 100 and 200 pounds an hour. Yeah, and you can do it yourself. You can go online and you can check. So we've gone and found these are all on public websites. So my guy Uma Shabir charges 153 pounds an hour. It's kind of wild, guys. This guy, man like Tom, 185 pounds an hour. So guys, if you go on the market, you can see people really charge ridiculous prices per hour for tuition. Yeah, it's kind of wild. Yeah. Which means for just an average tutor, guys, you pay about £4,800 in a year for a private tutor. Yeah. And this is based on a £60 per hour model. So if you're doing 2 lessons a week, £120 or £480 a month. So we're comparing it against what we give you. So you'd spend close to £5,000 a year for tutoring. And you still don't get these, you still run into these problems, right? Even if you have a private tutor. Time-consuming logistics, selecting a tutor, scheduling lessons, managing timetables, uncertain quality, guys, few reviews to gauge effectiveness, no free content to assess the teaching style. For example, you guys, yo, Tanish, welcome back, dude. With me, for example, the reason a lot of you are here is because you've seen me on TikTok, Instagram, etc., right? So you know what I'm like as a teacher before you've even basically bought anything, yeah? So I'm giving you guys this for free. You guys know how I teach, yeah? Lack of resources. There's no recorded sessions or extra study material. Usually people just give you questions out of a textbook, right? And then inadequate preparation. If you've ever done private tutoring, most likely they just open up a textbook and say, yeah, let's just go do some questions, right? And this is why we made MyEdspace, yeah? Let's compare the value. So between having a private tutor and someone like me. So we know from earlier that a tutor would usually be charging for 2 lessons a week about £5,000 per year, and this is based on £60 per hour. If you want someone really experienced, a fully qualified teacher, top uni, etc., you could be paying about £8,000 a year. Or you could study with me and my team, where you're talking about £810 per subject per year, 5 times cheaper. This is over the course of the whole year, guys. Yeah, depending on the course. And right now, guys, like I said, we've just opened up the courses. We're actually giving 40% off if you join before September. Yeah, so it's 5 times cheaper than a standard tutor, and now we're giving an extra 40% off, so nearly 50% off of that. So this is what it would look like. But for you guys, for being with me right now, this is how much we're charging for the whole year. For the whole year, this is what it looks like. And this is for twice a week. Yeah. For tens of... Whoops. What's going on here? Tons of content, free content. This 597, guys, is for the personal mentor. Yeah. I can't lie, guys. When you break it down per hour with these numbers, it works out to £2 an hour. Yeah. So, I think the value is clear. Yeah. £2 to £3 an hour. And you're getting a mentor, getting all these lessons with me. It's all recorded. You're getting all the homeworks. You're getting all the video solutions. You're getting all these free resources. I'll tell you guys a bit more how to do it, but just remember the code word summer 2024. Yeah, just remember 2024. Just make a note of this. And also, guys, there's a 14-day full refund money back guarantee. Yeah, so for example, if you bought it in September when the course starts, you have 2 weeks to decide if you even want to keep it. Yeah, so basically today you can just lock in, say, look, I want to just get the course. Then you have until the 2nd week of September to change your mind. Yeah, so there's no risk there. You have time to change your mind. Yeah. And why stop at just maths? Guys, we have all the subjects now. So been working tirelessly over the last year to employ Laura, head of biology, Brooke, head of physics, Davinder and LaJoy for head of chemistry. And Louis, in English, is doing the uni prep course. So Laura, head of biology, BSc from Manchester, over 15 years of teaching experience, head of biology. And she also is a leading biology examiner. So she used to write questions for exam boards. Yeah. Brooke, head of physics at Mindspace, first class honors degree from Michigan State University, a master's with distinction from planetary science at UCL, over 6 years of teaching experience, including head of physics positions. Chemistry, LaJoy, head of chemistry AQA. She has a first class MSc from Oxford University, over 10 years of teaching experience, head of science positions. Davinder's, so she's going to be doing AQA. Davinder's going to be doing OCR for chemistry. He has a first class MSc and PhD from UCL and over 8 years of teaching experience, achieving 48% A* in 2013. Now, Louis, guys, a very important position at Mindspace. So head of English, he has a bachelor's from Oxford and a master's from Cambridge. And he's actually doing a PhD right now in philosophy at York. This guy is, guys, as an academic, this guy is next level. So he would help you with your applications to universities. So over 9 years of teaching experience and head of sixth form running UCAS workshops. So that's all of us. Yeah. We also have Dario. So the year 12s won't be here, but Dario, he's Imperial, PhD, all of that stuff. He helps me a bit with maths. Yeah. But this is the whole gang. I'm covering Davinder's head. We basically look the same anyway, but yeah, Avengers lineup. Trust me, the Avengers of education, changing the game out here. And now we're actually doing something known as the ultimate pass, where you get 3 subjects at a major discount. Yeah, so it's basically like, what is it? It's like this with a bit more discount for 3 subjects. Yeah, and like I said, guys, it works out to £2 to £4 per hour. Yeah, and this for 3 subjects, you'd be having like 6 hours per week. And we'd basically look after you, yeah? Also, we can split the price into 4 equal installments. I think someone was asking, yeah? So you don't have to pay all this at once, guys. You can break it up into 4 installments. That's okay. Not a big deal, yeah? Maths is interesting, Irena, because maths across all the exam boards is basically the same, yeah? There might be like 1 or 2 mark things that are slightly different. Like in statistics, people who do AQA or OCR don't need to know how to work out PMCC on the calculator, but otherwise it's all the same. Yeah. So the ultimate pass, this is what it would look like. So if you guys split it into 4 installments, this is what it would look like. Yeah. But this is for all 3 subjects. Yeah. But yeah, limited time offer. And this is all you need to do. Okay. So guys, summer 2024, if you're interested, the number is in the description of the YouTube video. So if you guys click the description, can you see there's a number there? All you need to do is quote summer 2024. That doesn't lock you into anything. So you guys can just go in and say, look, I'm interested. Can you guys tell me about the price packages? What do installments look like for 1 subject? Carla, so this is the 1 subject thing, right? Just message the number. Say, what does it look like if I want to split it? But for everything, guys, we can split the payments. You don't need to pay all of this up front, yeah? All you need to do is get that number and say summer 2024, and they'll sort it out, yeah? Unfortunately, Dark, I don't have a Edexcel further maths course. This is also the timetable next year. So if you guys are interested in seeing timings. Yeah, but if you guys have any questions, let me know. Neil, when are you going to release the full course structure? I'm already signed up for the course, so what year 12 content should I recap? Yo, Boris Johnson. I mean, before the year 12 course starts, it's actually Dario that's going to teach year 12. It's all my content, but Dario's going to be delivering it. That was this guy, Dario, the mega genius. You don't need to worry about what do I need to recap. We recap it for you when you start year 12. Yeah. No, Hassan, you could do it for the normal stuff as well, like the normal subjects. Not for all three. You don't have to. Yeah. Can I do the course, but just the stats part? Carla, yeah, you can, but that you would have to wait till February, right? But like, in terms of in February, the price you pay for just those 2 months work out to be like a third of the cost of the full year. So you're getting 1 month for the cost of what you would be paying for the full year. So you might as well just do the full year, in my opinion, but that's up to you to decide. But we do statistics mostly in February. Would I be able to ask further? Yes, Kai. So like if you take the normal maths, for example, the mentors, they're still able to help you with further maths questions as well. Yeah. Do I mean you? British. I mean, you said year 12. Oh, I see. You mean what year 12 content should I recap? You mean going into year 13? Again, don't worry about it. I revise it with you, so don't stress about it. Don't be consciously thinking, guys, what do I need to remember from year 12? Like, I sort you out. The teachers will sort you out. That's the whole point, guys. We're here to look after you, to make your journey through year 13 as smooth as possible, mate. We want OCR Chem instead of A. Yes, Charlie, just make sure. So with OCR, you would be with Devinder, right? So that would be here on a Thursday. Yeah. Oh, yeah, there's 2, sorry. So it depends. So you can see here, guys, chemistry on a Wednesday. If you're in AQA, you'd be with LaJoy that time and Devinder OCR. Then Devinder would be on a Thursday or Friday here if you're doing AQA. Yo, Sharif, how's the Algerian biscuits? Samaya, biology... I wouldn't be able to tell you what Laura's doing there. Can you just drop a message to that number? They'll be able to tell you. Because we've now employed another biology teacher, so I'm not sure what's going on with biology. But my team will be able to tell you, yeah, what's going on with biology. Sharif, guys, one massive tip is actually do the homework and you'll get that dub. AA star, let's go. Carl, we do have sibling discounts, yes. So just let the team know. When does this all start? So it all starts not the first week of September, but the one after. So this all kicks off on the 9th of September, guys. So this all kicks off on the 9th of September. So I could put the... Oh, here's the link. So there's actually a link, guys. If you either want to click this, there's like that's a WhatsApp link. But there's also a number there. So it depends what you guys want to do. Yeah, so basically there, you just need to type summer 2024. And then my team will look after you, yeah? When you do exam prep for AQA, they have a paper on stats and pure stats and mechanics. So Aisha, when you're actually revising with me during the course and not exam season, we just do a pure paper. And it's similar to OCR as well. They have a similar structure. We just do a pure applied every single week, but then during exam season the structure changes slightly. But in terms of revision, it doesn't make a difference what your paper structure is. We're just revising all the content, right? But yeah, hope that helps. Okay, guys, I think we'll call it then. If you have any questions, just click that WhatsApp link or message that number with summer 2024. My team will be able to plug you with it. But otherwise, guys, well done today. I look forward to seeing you in the next lesson. Have a nice rest of your week. Peace out, guys. I look forward to seeing you a lot of you on the main course in September. It's going to be lit. I see a lot of my year 12s are here as well. We're all going to smash in year 13. Well done, you lot. Peace out. Peace out. Have a good one. Nice one, guys. Peace out. See you guys.